Okay, after we've learned how to draw a free body diagram, we're now going to talk about, from the free body diagram, how do we work out the net force? So sometimes we have forces that work together. Okay, so in some cases, some forces are acting in the same direction. And what that means is it's going to help each other. So say, for example, if I have an object and I got person 1 who's pushing to the right at 10 Newton, and then I got person 2 who's pushing to the right at 12 Newton, does it make sense that they're working together? So the overall force would be 10 plus 12. But then what if I tell you there is now an extra person who just kind of like to fight and say, hey, you know what? I'm going to push this way at 8 Newton. So how do I work out the net force? When they're working in opposite direction, the work is now working against each other. So in this case, I'm going to have to go 10 plus 12, but then minus 8 to get the net force. Okay, and so the net force is basically the sum of all the forces together, but it does matter what direction it is. So to calculate net force, how do you do that? Okay, first of all, you pick a positive direction, and then you would give the force a positive or negative value depending, and then you add them all together. So say, for example, this question, okay? So when I have a 15 newtons to the right and a 10 newtons to the left, first thing you need to do is think about which way is positive. I'm going to say the right is positive. And so to find the net force, if I say right is a positive, then I would take my right minus my left. Does it make sense? If I have 15 newtons to the right and 10 newtons to the left, it would be 5 newton. And to get that, I would take the forward minus the backwards. So I have 5 newton. And don't forget, this is a direction, so I'm going to have to write to the right. All right, now you have this picture. 14 to the top, 6 to the top, and then 17 to the bottom. So if I ask you, what do you think the direction of the net force should be? I should be going up this way, right? Like if you think about it. So if this is the positive, if you made a mistake, it's okay. All you have to do is flip the direction. So I'm going to write the F net right now, okay? And I'm going to go up, plus up, minus down, right? I have to add up all the ones to the top first, and then subtract the one at the bottom. So 20 minus 17, I have an overall force of 3 Newton and is going upwards. Okay, now a bit more numbers going X and Y. Okay, so you're gonna have to split up studying the forces along X first, and then so basically you're gonna have to analyze it based on everything that's going along X. So let's take a look at the forces that are going along X. Do you see there's 3 of them? Okay, so I got 18 on the right, 9 and 6 on the left. If you do the math, 9 plus 6 is 15. So the right-hand side has more. So I'm going to say that along the X, we're going to say that the acceleration is, the forward direction is going to be towards the right. So when we write out F net, the net force is going to be the right minus the left. This direction always tells you which one do you start with. So I would take my right minus my left. Be very careful. I'm minusing 9. I'm minusing 6. Okay, because if you wanted to, like if I don't do this equation, if I ask you, hey, what's the overall forces that are going on the left-hand side? It's 9 plus 6, and it's 15, right? So it's almost like I got 1/4, that's 15 to the left, 18 to the right. So if I say like, oh, what's a net force? You would probably look at the picture and be able to get me 3 newtons. So let's do the math here. 18 minus 9 minus 6, it equals to 3 newtons. So this is the way to do it. I'm going to do a common mistakes. Okay, common mistake is people go right minus left. They would go right minus, and then they look at, oh, the 9 and 6 is together. If you want to do that, your answer is not going to be right. I know overall is 3 newtons. If I go 18 minus 9 plus 6, I have made it 15, a lot bigger. If you want to do the adding, then you're going to have to do the brackets. So let's just not do that, okay? So just be careful. Just when I'm subtracting, if I have 2, I have to subtract it 2 times. Okay, now let's take a look at the y direction. So along the y direction, let's see how many forces I have. I'm going to change the color of highlighter. Okay, the y forces has 7, 13, and 16. Okay, and 7 plus 13 is 20, so up is higher. So I'm going to set my directions to be going upwards. Okay, so up is the reference that I have. So I still start out with F net. It's going to be up. So 13 and 7 are both up, minus the bottom, which is 16. So 13 plus 7 minus 16, that gives me 4 Newton that is going upwards. Okay, I forgot to say that this is to the right. So make sure you put the direction down. Last question. A book is pushed across the table with an applied force of 12.5 newtons. The force of friction is on the book is 8.8 newtons. Both the normal force and the force of gravity are 10. Calculate the net force on the book. So this object, draw your free body diagram. It has an applied force. And I'm going to label it FA, and they tell you in the question is 12.5 Newton. And then I have FF, force of friction. So I'm going to write F with the symbol of lowercase f, and it's 8.8 Newton. And then they tell you normal force. Normal force is going upwards from the table. So Fn is 10. And then they then said force of gravity, Fg, is also 10. And they're saying find the net force. I have forces that are going along x and y, so that means I need to split it up again. I'm going to study all the forces that are going along x. So I have this one and this one. Okay, so 12.5 to the right, 8.8 to the left. So I'm going to assume that it's going to be going to the right. So net force will be right minus left. The right, I'm going to write the name first. The right is FA minus FF. So putting the numbers in will be 12.5 minus 8.8. Punch it in your calculator. So 12.5 minus 8.8 equals to 3.7 newtons to the right. And then along y, I'm going to study the forces. Okay, this time I have 10 going up and 10 going down. So I don't know which side is the correct way. Does it matter if I go 10 minus 10 or 10 minus 10? Do you see how it doesn't matter if I go up minus down or down minus up, because they're exactly the same thing? So I'm just going to decide and say I'm going to do up minus down. Okay, so F net in this case is going to be Fn minus Fg. And as I said, it doesn't matter. If you want to write it Fg minus Fn, it doesn't matter, because you will end up with the same answer because they're both 10. So 10 minus 10 is 0. So there's no direction. There's no net force along the y, only along the x.